Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civey, and I've spent the last couple weeks discussing air change rates, laminar flow, air curtains, and some other things. So now we have all the pieces that we need to discuss air distribution requirements of ASHRAE Standard 170, ventilation of healthcare facilities. ASHRAE 170 defines the ventilation system design requirements for patient care areas and related support areas of healthcare facilities. This includes hospitals, nursing facilities, and outpatient facilities. It covers new buildings and additions to existing buildings. So the standard covers from the air handler design, filtration, and many other areas of healthcare design. But since Titus is an air distribution company, I'm going to kind of focus around air distribution and ventilation and the systems that are affected by it. So maybe we'll come back to some of the other sections in future podcasts. So the first sentence of the air distribution systems section, which is section 6.7, is maintain the pressure relationships required in table 7.1 in all modes of HVAC operation. So if you remember from the positive and negative pressurization podcast, you can use room pressurization to keep things in or out of a space. So some of the spaces that the standard shows as positive pressurization are operating rooms, procedure rooms, delivery rooms, and trauma rooms. A couple spaces to keep negatively pressurized are gas storage areas, ER waiting rooms, triage areas, and ER decontamination areas. Let me make a little bit more room here. There are also some areas that have no pressurization requirement, such as recovery rooms, immediate care areas, intensive care areas, and burn units. So table 7.1 is 3 pages long, so there are a lot of other areas that aren't on this list, but you get the idea of what types of spaces are kept positive or negatively pressurized. You can see that operating rooms are positively pressurized to keep things out of the space, and gas storage is negatively pressurized so that if something happens in the space, the gas doesn't get out. Now, some areas don't have a requirement, but there's also a statement in ASHRAE 170 that says that recovery rooms, intensive care areas, immediate care areas, and burn units do not require pressurization relationships to adjacent areas, but that they do need to be served by a fully ducted return or exhaust system. Okay, now let's make some room and talk about air distribution devices. So a couple things you need to know about air distribution devices used in healthcare. First of all, you need to be able to clean the surface of the diffusers, and in operating rooms, you need to be able to clean them internally as well. You also have to install security grills in psychiatric seclusion and holding patient rooms. Table 6.7.2 of ASHRAE 170 tells you what outlet classification to use for the different healthcare spaces. For instance, operating rooms need to have non-aspirating supply diffusers from Group E. The groups correspond to outlet classifications in the ASHRAE handbook, but these are basically the laminar flow diffusers I discussed a couple weeks ago. Okay, let's move this out of the way and talk about ventilation requirements. Section 7 of ASHRAE 170 gives minimum space ventilation requirements. This section says that the general airflow should be from clean to less clean areas. We talked about that a little bit when we talked about pressurization. It also says that if VAV systems are used, it can't compromise the pressure relationships. So you don't want to turn down your VAV box without adjusting the return side as well. So say we have a space and you're putting in 500 CFM into the space and exhausting 400 CFM to keep it positively pressurized. If you turn your supply down to 300 CFM without adjusting your exhaust side, so you still have 400, now you're no longer positively pressurized, now you're in negatively pressurized space, and this would be bad if it's an operating room and someone's having surgery. Table 7.1 shows the minimum air changes per hour required for a given space based on the type of space it is. For instance, in an operating room, you need 4 outdoor air changes per hour and 20 air changes per hour. Make a little bit more room here. Okay, so this is basically saying that you have to bring in the equivalent of 4 outdoor air changes as part of that 20 air changes. So if you have 20 air changes and that equals, say, 20,000 CFM, you have to have your outside air dampers set at about 20% so that you can get the 4,000 CFM of outdoor air into the space as well. So one more thing about air changes. If the space is supposed to be positively pressurized, the air changes are measured by what's supplied to the space. And if the space is supposed to be negatively pressurized, it's measured by what is exhausted from the space. Okay, let's move this one out of the way now. So I've talked a lot about table 7.1. 7.1 has a lot of good information in it. It also shows the design temperature and relative humidity ranges for each type of space. For instance, operating rooms and delivery rooms are supposed to be 68 to 75 degrees and 20 to 60% relative humidity. Whereas recovery rooms can be 70 to 75 degrees and 20 to 60% humidity. Okay, let's move this over and talk about one last section, filtration. ASHRAE 170 calls for 1 or 2 filter banks depending on the space it's supplying. Table 6.4 shows what MERV rating each bank needs to have. For instance, an operating room needs to have 2 filter banks, with filter bank 1 having a MERV 7 rating and filter bank 2 having a MERV 14. But an admin area may only need 1 filter bank of MERV 7. The standard also tells you where the filters need to be. Let's draw a quick air handler with our airflow moving in this direction. So the first filter bank needs to be installed upstream of the heating and cooling coils so that all the mixed air is filtered. So we have a filter, and then here's our cooling coil and our heating coil. The second filter bank needs to be installed downstream of all wet air cooling coils and the supply fan. So we have our fan here and our second filter bank here. And the second filter bank also needs to be sealed. So that covers the highlights of ASHRAE Standard 170. Obviously, I couldn't cover every detail of this presentation in 5 to 10 minutes, but it gives you an idea of the topics covered and some of the important points in the standard. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.